This conference will now be recorded.
Very good evening, students. We have been discussing PYQs from JEE Mains papers. So today we'll be discussing excuse me. So yeah, suddenly I got a call. Anyway, so let us continue. Let me change the ink over here. Okay, so today we'll be discussing questions from the 11th part. So from this particular question paper 2021 31st August shift to 1. All right, so let us start our discussions. The question says a uniform heavy rod of weight 10 kg, meter into meters and kg meter second square. Okay, I hope you have understood this. Kg meter. So actually the Newton is actually m into g in this case. So it means m into g. So kg meter per second square. So in that way the unit is given anyway. So and the cross sectional area has been given 100 centimeter square. The length is 20 centimeter is hanging from the fixed support. Okay, Young modulus of the material of the rod is given as 2 into 10 to the power 11 Newton per meter square. Neglecting the lateral contraction, find the elongation of the rod due to its own weight. Okay, so let me give you the options over here. Option A is saying 2 into 10 to the power minus 9 meter. Option B is 5 into 10 to the power minus 8 meter. And option C is 4 into 10 to the power minus 8 meter. And option D is 5 into 10 to the power minus 10 meter. Okay, so the question is heavy rod. Okay, it is fixed. Suppose this is a support, it is actually fixed like this. I'm sorry, this is uniform rod, right? So it has uniform cross sectional area. Okay, I hope it is somewhat uniform. Anyway, so this has got a length. Okay, length 20 centimeter. Okay, it has got length 20 centimeter. So it is very simple, right? We know Young modulus is equal to stress by strain. It is the ratio of stress by strain. All right. So in this case, stress will be weight by area, and strain will be suppose delta L by L. L is the original length, okay, and delta L is the change in the length. So I have to find out what is the change in the length. Let me just do it. See, I just want to find out what is change in the length. Delta L divided by W by A Y into, okay, so delta L by L, so this L should go here. Okay, W into L divided by delta, sorry, A into Y. So this will be the change in the length. But in this case, one just important concept you have to remember. In this case, L should not be taken as 20 centimeter. This is not 20 centimeter, it is 20 by 2 centimeter, because we'll be considering the center of mass. Okay, the position of center of mass, from where the, or the center of gravity, since it is the uniform rod, the stress will be actually acting from here. Okay, so weight will be acting from here, from the center of mass, not from there. See, not from this end. Okay, so that's why this length we have to consider as the original length, that is L. L is then 20, see, 10 centimeter. Okay, so this is the important point you have to remember. See, this kind of problem, even see, I'll just give you one more example. When there is a problem that a portion of chain is just hanging from a table, okay, table. So in that case also, the center of mass, see, suppose the length L is hanging, the center of mass will be taken as L by 2, and in that way we have to consider the problem. So yeah, so I hope you remember this chain problem. All right, so similar to that here it is. Okay, so otherwise things are all right. So we will just write L by 2 over here. If I take the whole thing as L, then L by 2, or if I have taken L is equal to 10 centimeter, that's all. Okay, so now we'll just put the values to get the answer. Let me write it here. Delta L is equal to W into L divided by A Y. Okay, so W, the weight is given as 10 kg. Okay, so that is 10 only. See, L will be 10, but that is in centimeter, so I have to multiply 10 to the power minus 2 over here, divided by A. A is the area of cross section, that is given as 100 centimeter square, so I have to multiply 10 to the power minus 4 along with that to get meter square, and Y is given as 2 into 10 to the power 11 Newton per meter square. Okay, now it will actually give you in meter. Okay, so let me see in which unit. Okay, so 8, so there are all. Okay, so let us do this calculation over here. So you have got, see, these two will cancel each other, so you have here 10 to the power minus 2. Okay, 10 to the power minus 2, so you will get 10 to the power 10 to the power 9 over here. So when it goes over, yeah, so 10 to the power 9 divided by 2, so it will be actually 5 into 10 to the power, it will be minus 9. So 5, oh, I see, this will be 0.5. Okay, 0.5, just let me see once again. I have 0.5. Okay, 0.5 into 10 to the power 10 to the power minus 9. Yes, so yeah, either we have to write 0.5 into 10 to the power minus 9 meter, or we have to write 5 into 10 to the power 10 meter. So what are the options given over here? Okay, so it is like this: 10 to the power 5 into 10 to the power 8. Let me just check whether you have done some mistake. Okay, 100 centimeter, 10 kg, 20. Yes, that's fine. Everything is fine over here. So this is, yeah, 0.5. 0.5 means, 0.5 means 5 by 10. So it will be actually 10 to the power 9 over here. It goes, I'm just doing a little mistake over here. Okay, I see I have options over here. See, I think I'm right. So it will be 5 into 10 to the power minus 10. Yeah. So it is actually 5 into 10 to the power minus 10. Yeah, I did not see the last option, so that's why I was in confusion. Okay, so it is all right. So 5 into 10 to the power minus 10 meter is the answer. Okay, so all right. We'll go to the next problem. Okay, so this problem is really very interesting. This is from plane mirror. So you see these are actually suffix m1 m2. Okay, you can understand that the plane mirrors m1 and m2 are at right angles. Okay, these are two plane mirrors, they are at right angles to each other. A point p, a point source p is placed at a at a distance, okay, a meter from m1, see, from m1 a meter, and 2 a meter from m2 respectively. So the shortest distance between the images thus formed. Look what will happen. There will be image formed here somewhere at 2a. Okay, so here 2a distance away, somewhere here 2a. Okay, so for this, since it is plane mirror, at the same distance it will be like here somewhere. Okay, so this is okay, so there will be one image over here. Let us say this is I1 and this is I2. Okay, so generally if we consider these two images itself, look, this distance is actually, this is 2a, this is 2a, 4a, and this is a, this is a 2a. Okay, so I have to find out the distance between them. So that means this one. Okay, let me show you the proper figure over here. So see, we need to actually find out the distance between these two. Actually, this hypotenuse of this right angle triangle. So we have to find out this hypotenuse. So this distance is square root of 4a square plus 2a square. Okay, so you'll get 16a square plus 4a square. So that means 20a square. So a into 20. I can do one thing. I can just write a 2a root over 5. See, there is actually given, see, this 0.5, sorry, square root of 5 is 2.3, square root of 5 is 2.3. So if that is the case, look, 2 into a into 2.3, so it is 4.6a. Okay, 4.6a. And see, there is an option over here, so option C will be the correct answer for this question. Okay, so this is done. Let us go to the next problem. Okay, so this problem, see, there are two lists, list 1 and list 2. We have to match the dimensions with the quantities. Okay, we have to match the dimensions of the quantities given in the list 1 with the dimensional formula in the list 2. Okay, so torque, let me write one by one. So see, a, okay, let me just do the torque over here. So torque is actually rf sine theta. Sine theta is dimensionless quantity. This is f and r. Okay, so this is ml, this is ml to the power minus 2, that is the force, and this is l. So I'll get m l square to the power minus 2. In fact, this has unit of energy or work done. Okay, ml square to the power minus 2, so this 3, so a will match with 3. Okay, a will match with 3. All right, now let us go for the impulse. Impulse is actually uh, we can do in two ways. Impulse is F into T actually. F into T. Force into T. Impulse is denoted by I or J. Let me denote that with J. So J is actually F into T. Force into force time, that force into time. So we know ml to the power minus 2 into T. Okay, so your ultimately dimensional formula will be m l to the power minus 1. Let us see ml to the power minus 1, so 1. So B will actually match with 1. All right, so let me clean this portion again, so that we can do the other one. Okay, tension is simply force, right? Tension is simply force. Okay, tension is simply force, that is ml to the power minus 2. So this will be 4. So option C will match with 4. Let us see the D. Surface tension is actually F by L. F by L is equal to surface tension. Okay, let us denote that by S. Okay, surface tension is F by L. F by L means m to the power minus 2. So it is actually matching with 2. So it will be m to the power to the power minus 2. L will not be there. M to the power minus 2. Okay, so D will be equal, so T. Okay, so this is, so A3, let us check. A3B, no, this is not the one. A3B1 C4 D2. Okay, so option C will be the correct answer for this question. All right, so let us go to the next problem. Okay, so this is very important problem we have to solve here. A car is moving in a plane incline at 30° to the horizontal with an acceleration of 10 meter per second square. See, this is a car. You can see that a car is moving upwards. Okay, this is parallel to the plane upward. Okay, car is moving along this inclined plane in the upward direction with an acceleration. This is A. So this acceleration is 10 meter per second square. And inclination of this plane is 30° with the horizontal. This is given. A bob is suspended by a string from the roof of the car. You can see that this is the bob which is suspended from the roof of the car. The angle in degrees which the string makes with the vertical is dash. Okay, you have to find out that actually. Okay, so while it moves, see, uh, see, you have here, see, in inclined plane, first of all, the G will actually act vertically downward like this. Okay, but it will actually makes an angle 30 over here. Okay, 30 over here. So this is actually mg cos of theta that you know. All right, and mg sin theta which will act this way. Okay, so mg, if the mass of this car is m, so mg sin theta will act in this way. All right, now for the bob here, for the bob, see, it is already in the inclined plane. See, mass should have gone like this, but it is actually this theta, this angle is not only theta. Actually, see, I would have drawn here. Let me draw the figure over here. Okay, so now the pendulum, so this is the vertical direction to this plane, but real vertical is this one. Okay. Now your pendulum bob is actually like this. Okay, this is the pendulum. Okay, and this is the perpendicular to the plane. Okay, and this is actual vertical to the ground, you can say. This is the actual vertical to the ground. Okay, now this angle is theta, I know. 30 degrees, sorry, this angle is 30 degree. Okay, I am actually drawing. Okay, so let us just excuse me, let us take this angle. So what is this angle actually? This angle is the vertical. Actually, this is the vertical with this this car itself. Okay, in this car, this is actually the vertical, right? This is the vertical. So I can take this as this actually. So this angle is actually not, see, the original vertical will be like this as I had drawn earlier, but we have to actually, I'm sorry, so let me just draw it once again. Okay, this is 30 degree. So this will be actually, see, your G will be like this, G will be like this. So this angle will be 30 degree. So you look, if this yeah, so if this is vertical, exactly vertical to this, suppose this is the vertical one. Okay, so this is 30 degree, we know already. This angle is 30 degree, but we have to find out the angle, this angle, this much. Okay, so I'm sorry, this, look, this angle is 30 degree. Let me draw it properly. And this is some theta shape. I hope you have understood now. This is the bob in the car, which is here, you can see that. Okay, so you just just don't get confused with this free body diagram. Let me show you here. This is the situation. Okay, so you look here, G will be acting like this. So G cos theta, this is G cos theta. Okay, which will actually be like, okay, so this is generally, in general, if there is a block, N will be acting in this way. Okay, that is what we knew. Okay, now the situation is, see, we have to find out the angle with this vertical, because see, the vertical is like this now. Okay, we have to find this angle. Okay, originally vertical is this one, and with this vertical, this angle is actually 30 degree. Okay, but we have to find out the angle with the vertical to this support. Okay, this support, with respect to this support, it is the vertical. Okay, that is perpendicular to the inclined plane. So that is the vertical here. So this angle obviously is 30 plus something, some theta. I hope I'm able to make you understand. This is the situation here, right? Okay, so with this I have to check. So here look what happens with the bob. What are the forces acting with the bob? See, there are, see, if I just consider tension, so tension will be acting like this, so it will be like this. Okay, I mean, see, it will be actually kind of this, okay, parallel to the inclined plane, say, and like this. Okay, let me just do it properly. So it will be like this. Okay, all right, so the tension will act in this way. If this is theta, this is also theta, so t cos theta, and this way it is actually t sin theta. Now look, with this inclined plane, what we have along this direction. So at the equilibrium position, this angle is theta. Okay, so at equilibrium position, see, on the inclined plane, if I just take the whole system has mass m, in that case, you know, you will have mg sin theta in this direction, and since it is moving, see, on the bob there will be another pseudo force since it is moving in this direction with ma, so there will be a pseudo force acting in this way on the bob. Okay, on the bob there will be a pseudo force acting this way. So I can actually consider the equilibrium situation when ma plus mg sine of, sorry, this is not theta, this is 30, this is 30, this is 30 degree. Mg sine 30 degree will be equal to the tension. See this sine theta component, t sine theta plus 30 degree. Okay, theta plus 30 degree. Okay, so I think this is this way. Okay, theta plus 30 degree, theta plus 30 degree, the whole thing. Okay, theta plus 30 degree. Okay, let me clean it. It has become too much messy. Okay, so see, this angle is 30, this one, and this is theta. Okay, so this will be total 30 plus theta, the whole angle. So this will be okay. All right, so tension acting in this way, so this will be t sine of 30 plus theta. Okay, 30 plus theta along the inclined plane, and this way it will be cos of 30 plus theta. Okay, and in the vertical direction, see, vertical direction, it will be mg cos of 30 is equal to t cos of 30 plus theta. Okay, so this is the free body diagram over here. Okay, so if I take the ratio of these two, what I'll get, I'll just write in the other page. See, I have t, okay, t sine of theta plus 30 degree which is equal to mg sine of 30 degree plus pseudo force in the bob, that is m into a. Okay, here t cos of theta plus 30 degree, along with that there will be, okay, so mg cos of 30. All right, so here if I take, see, just divide these two, then I'll get tan of 30 plus theta degree is equal to, see, mg into half plus m into a divided by, so this is cos 30 degree, that means root 3 by 2, root 3 mg by 2 over here. So I'll just get this. See, m I don't know, I can actually cancel from both sides, like from the denominator and numerator. So 10, see, g is 10, so 5 plus this a is 10. So this I have got, so 2 into this divided by root over 3. Okay, so this will be actually 30, and see this g also is there, so this is 10. So you will get, see, 30, that means 3 by root 3, 3 by root 3, that means tan of 30 plus 30 degree, which is equal to root over 3. And we know tan 60 degree will be equal to root over 3. So this is actually equal to root over 60 degree. Sorry, tan 60 degree. Okay, now this and this argument we can equate. So from there we'll get theta plus 30 degree is equal to 60 degree, and that is giving you theta is equal to 30 degree. So here this angle will be 30 degree with the vertical. Okay, so 30 degree will be with the vertical. Okay, so theta will be actually 30 degree. All right, so with the vertical it will be actually theta, so that is 30 degree. I hope you are understanding this situation over here. All right, so we'll go to the next problem. So this problem is saying that a wire having linear mass density 9 into 10 to the power minus 4 kg per meter. Okay, that means mu is given for a strain. Okay, this is kg per meter, is stressed between two rigid support, that means this one. This is actually a problem from straight string with the support, and the tension of the support is like a string, in the string is 900 Newton. The wire resonates at a frequency 500 Hertz. The next higher frequency at which the same wire resonates is 550 Hertz. So I have to actually know or recall here what is the formula for the harmonics, or what are the harmonics generated in the straight string. So we know this will be actually mu is equal to P V by 2L. And you know this is actually P is actually 1, 2, 3, 4, 5. All even and odd harmonics are actually created in state string. Now here, according to this problem, see nu P is 500. Here this is V. This is the velocity of like a wave, stationary wave in the string of wave in the string or through the string, and that has got a formula. V is equal to root over T by mu. This we can find out anyway. So this is given as this much hertz, and nu just next one, nu P plus 1, that is 550 hertz. Okay. All right. So here, if I just take the differences of these two modes, nu P plus 1 minus nu P, that is 550 minus 500 hertz, that gives you 50 hertz. Okay. Now this I can write P plus 1 into V divided by 12, and this is PV by 2L, which is 50 hertz. Okay. So see, if I just take this, okay, so P will cancel each other, so we'll get actually V by 2L is equal to 50, right? So I have to find out the length of the string over here. Okay, we had to find out the length of the string in meter. Okay, so L will be V by 100. So what is V? V is square root of T by mu by 100. So what is this? T is given as 900 Newton tension, and this is 9 into 10 to the power minus 4 divided by 100. So this will actually give you, see, this will cancel, so this will be 10 to the power 6, square root of 10 to the power 6 will be 10 to the power 3, so I'll get 10 see 1000 by 100, that means it is 10. So length of the string will be 10 meter. Okay, so this is 10 meter. All right, so let us go to the next problem. So this problem is also very, very interesting. A particle of mass 1 kg is hanging from spring of force constant 100 Newton per meter. Let me tell you this. So there is a spring. So it is hanging. So there is a mass attached to it. Okay. It is just pulled. It is pulled and leave. Okay. So it was pulled and released, so that it executes simple harmonic motion. As you know, it will execute simple harmonic motion if you pull it and release. Okay, what will happen? What will be the result? The result will be SHM. Simple harmonic motion will be there in the spring. Okay, so the question says it executes free simple harmonic motion with time period t, and time period of this motion will be t. The time taken, the time when the kinetic energy and potential energy of the system will become equal is t by x. That means t, small t, is equal to t by x. This time the kinetic energy and the potential energy of this spring, which is oscillating in simple harmonic motion, will be equal. Okay, kinetic energy and potential energy will be equal. So what is this X? So look, this question is very simple question. I know. Let me just take the displacement. For SHM, you know, displacement will be a sine of omega t. I'm just writing initial phase to be 0. Okay, like this. Now let me find out what is kinetic energy. So what will be kinetic energy and what will be potential energy? Let me take at this particular displacement, arbitrary displacement, the kinetic energy will be half mv square. Okay, what is v? In case of simple harmonic motion, we know that it will be a into 1 minus y square by displacement square by amplitude square, y square by s square, right? I just put that. So this is velocity at any displacement y, arbitrary displacement y at time t. So half m, let us take this, m is equal to 1 kg. Okay, so let us take that as m itself here, m half m v square, that is half m, so v means this a square whole into 1 minus y square by a square. Let us keep like this. What is the potential at this particular displacement? That will be half k y square. Y is the displacement, right? Okay, so k is actually, see, it will be omega square into m. Okay, omega square into m. So let me write that, because we know k by m is equal to omega square for simple harmonic motion. So half m omega square y square. And according to the problem, at this particular time or at this particular displacement, potential energy is equal to kinetic energy. So I can write half m omega square y square is equal to half m a square omega square I think there will be omega over here, omega into a, so there will be omega square. Okay, so omega square whole into 1 minus y square by a square. Okay, look, then I'll have half m omega square y square is equal to half m a square omega square, this part, along with half m omega square y square. Okay, so these two, I'll just take together so that I get m omega square y square, and that is equal to half m a square omega square. Okay, omega square m omega square I can cancel from each other. Then what I get, y is equal to the displacement at which the potential energy and kinetic energy will be equal, is becoming, a by root 2. So this is the displacement. See, in the beginning itself, what I have written as displacement y is equal to a sine omega t. So let me just put it here. So y is equal to a sine omega t. So if I put this here, a by root 2 is equal to a sine omega t, then I get a sine omega t, a sine omega t is equal to 1 by root 2. Okay, that means sine omega t is equal to sine of pi by 4. Okay, so omega into t will be actually pi by 4. So from here I can get the t. Look how. So t will be, I think I have to clean this portion somewhere. Okay, let me just put it here. Let me write it here. So we have got omega into t is equal to pi by 4, right? And see, this t will be pi divided by 4 into omega. Again, omega we know omega is equal to 2 pi by t. Okay, 2 pi by t. Let us write that. So pi by 4 into 2 pi by t. That t I can take in the numerator. This will cancel each other. So t by 8. Okay, so dear students, look what I have done. I have actually found out what is the displacement at which the kinetic energy and potential energy are going to be equal. Now, in this formula or in this equation, I'm just putting that displacement so that I get a relation between t and small t, time, and the time period. Okay, so omega t is equal to pi by 4 I have got, and then I have just substituted omega in terms of t. Okay, 2 pi by t. So I have got t by capital A, sorry, the capital T, that is the time period, by 8. And here, if I compare with this, then I get x is equal to 8. And this is the answer. Okay, so this was also a good question. Now, let us go to the next problem. See, here the problem says a block moving horizontally on a smooth surface with a speed 40 meter per second splits into two equal halves, okay, equal parts. If one of the parts moves at 60 meter per second in the same direction, then the fractional change in the kinetic energy will be x by 4. Fractional change in the kinetic energy. Let me just explain the problem. See, suppose there is a mass like this. Let us take this mass to be 2m. It is moving initially with velocity 40 meter per second. Now, on the way, somewhere it actually breaks into two. One goes like this, and the another one, we don't know in which direction it is going. We'll just check it over. Okay, so it is actually, see, it breaks into two equal masses. So it is m, and this is also m. Okay, now this guy is moving with 60 meter per second. We don't know. Let me take the velocity of this guy to be v. Now the fractional change in the kinetic energy, that means kf minus ki divided by ki. This is actually fractional change. This can be mod. Okay, this is fractional change, and that is given as x by 4. Okay, we have to find out what is this x. So here, anyway, let us find out this velocity by applying conservation of linear momentum. Conservation of linear momentum. Okay. So what is the initial momentum? That is 2 into 2m into 40 meter per second. So it will be actually, so this is initial momentum. This will be 80 am. Let us take that as kg. Kg. So okay, so this m will be there because I have taken 2m. So that's how m is there. Kg meter per second. Okay. But what is the final one? So final one will be m into 60. So 60 m plus m into v. I'm just taking as plus. So this is also in kg meter per second. So these two will be equal. Okay. Linear momentum in any case will be conserved. Okay. If I just do that, then see what I get. I get m into 60 plus v is equal to 80 m. Okay. So from here, this m goes off. So we get actually 60, sorry, 60, 80 minus 60, that is, okay, this is 20 meter per second. So other one is also moving in the same direction because the positive sign is positive. So other one is also moving in the same direction with velocity 20 meter per second. Okay, now we have to find out what is the final and initial kinetic energy. So final kinetic energy will be half m 60 square plus half m 20 square. Okay, so this will give you, so this is 30, so 36 800 m, and this will be 200 m. Okay, this is actually kinetic energy in joule or whatever you say. So this will be actually 2000 m. What is initial kinetic energy? That is half m. M is 2m here into 40 square. So 40 square is actually 1600 and divided by this. Okay, this is actually 1600 m. Okay, so let us find out the difference. Delta K is Kf minus Ki, that is 400 m. What is initial one? Initial we know, so we will get fractional change. Fractional change in K kinetic energy equal to 400 m by 1600 m. That is the initial one. So you get 1 over 4. Okay, 1 over 4. So let us compare with this one. So this is x by 4, that is compared with 1 over 4. So x is equal to 1. So in this case, the answer is 1. Okay, let us go to the next problem. Okay, so this problem says when a rubber ball is taken to a depth of dash meter in deep sea, its volume decreases by 0.5 percentage. Okay, that means you know the delta v by v. This is in percentage. If you multiply 100, so you'll get in percentage. Okay, or we can say delta v by v is 0.5 by 100. Okay, so this is given here. The bulk modulus of the rubber is given, that is 9.8 into 10 to the power 8 Newton per meter square, and density of the sea water is also given, that is 1000 kg per meter cube, and G we have to take as 9.8 meter per second square. So we have to find out what is the depth. We have to take it. See, bulk modulus is given, right? Let me just find out what is bulk modulus. Actually, bulk modulus K is minus del P divided by del V by V. Okay, this is actually my bulk modulus. So let us just take the modulus. Okay, so we get delta P by delta V by V. So if we consider it with respect to the sea level, so this delta P I can write as H rho and G. Okay, H rho G. So from there I have to find out what is this H. So H rho G is equal to the bulk modulus into delta V by V. Okay, so from here H is equal to K delta V by V divided by rho into G. So let us put the values. 9.8 into 10 to the power 8. This value is unitless, so this is 0.5 divided by 100. Here, so there will be 10 to the power 3 over here. Okay, so 0.5 into 10 to the power 3 means 500. So this is in meter actually. Okay, so this will be 500 meter. Okay, so it is important here to remember the definition of the bulk modulus. Rest of the things are fine. Okay, so let us go to the next problem. I think, okay, so yeah, so I think this is the last problem for this session today. We have few more problems from both 11th and 12th part. In the next class I'll collect all these problems together, 11th part and 12th part, and finish this paper. Okay, discussion of this paper 31st August shift 1 paper will complete in the next session, taking all the questions together, 11th part and 12th part. Okay, so thank you for your patience. Bye for today.